I've been working in IT consulting for 7 years. And when
Mm-hmm.
I first started, data analytics was hardly on most companies' radars. And then
Mm.
it kind of hit that peak of expectations where every company wanted to analyze as much data as possible. And
Yeah.
then it kind of went to that trough of disillusionment where I think a lot of companies realize that there isn't a lot to be gained from some of their data they might have. And so
Mm-hmm.
then they just started to take it more seriously and focus on where they could actually get more bang for their buck.
Hi, Curtis. Welcome to IT Global Direction. My name is Rorisang Hlahatsi-Baloyi. Curtis, please introduce yourself. Where are you in the world today, and what's the hot topic for today?
Hi, my name's Curtis Nybo. I'm work out of Calgary, Alberta, but I move back and forth between Saskatchewan and Alberta, Canada. And the hot topic for today will be artificial intelligence and data analytics.
Awesome. So, what is artificial intelligence, Curtis?
Well, it's a pretty broad topic. So my background actually is in finance.
Mm-hmm.
I have a bachelor's degree in finance, but then around 2014, I started to get into data analytics and artificial intelligence. And overall, it's a very kind of old
Yeah.
discipline. It's been
Mm-hmm.
around for a long time. People have had data to crunch for years and years and years. But then since the advent of the PCs, so starting way back in the 70s, they
Mm-hmm.
started to take advantage of a lot of that data, be able to put it through those punch cards into the real old IBM computers. And that was kind of the start of the data analytics. And they started doing larger mathematical problems using those computers. And then in the 70s through 90s, it started to kind of proliferate where researchers started coming up with a lot more advanced algorithms
Mm-hmm.
and a lot more advanced mathematical formulas and computer architectures to be able to solve more advanced problems. But the
Mm-hmm.
problem they ran into back then is the lack of data. And
Mm-hmm.
so as we move forward to 2010, the 2000s through the 2010s, that's when you started to see that data problem start to disappear. So as the internet became available to everyone around the world, everyone started generating more data, companies started generating more data and recording more information. So then you went from having a computer problem way back in the 50s, which was solved starting in the 80s through
Yeah.
90s. Then they ran into a data problem where they didn't have enough data, but they had the models. And now that data problem has been pretty much solved. And that's kind of where we are now, moving into where we have a huge amount of data that we've been able to apply a lot of these real old um, models that were developed in the 80s. And
Mm-hmm.
around the 2010s, around mid 2000s, around the 2010s, they started to actually really put that initial research that was developed in the 80s and 90s into use and into practice and applying it to huge data sets. And then from there, they were able to improve those models exponentially. And that's kind of where we are today. So data analytics in a nutshell is using a lot of high-powered computers to crunch a lot of data. And that's kind of the timeline in my eyes that I kind of see
Yeah.
how it evolved over the years. And so now that we have not only really powerful computers, we're in an era now where that almost supercomputer capacity is available to just about anyone through cloud providers. So where in the early 2000s and even around 2010, you could probably only get access to a lot of that computing power if you're part of a university or part of a large organization that had that. But now
Mm-hmm.
just about anybody can. And so you can kind of see the exponential growth with the combination of that large amount of data and the large amount of available computing power for pretty much
Mm-hmm.
anybody. And so then
Yeah.
you have the explosion of analysis and research in all disciplines. So data analytics and artificial intelligence can be applied anywhere.
Yeah, I see like a strong relationship between data analytics and computer power and artificial intelligence. My interest now is to understand what types of artificial intelligence capabilities are out there. So I know in recent conversations there've been a lot of talks around natural language processing on ChatGPT, but I'm assuming there's others. And can you just give us a view on what other AI capabilities are out there?
Oh, absolutely. It's in everything we pretty much do. So one of the main ones that people unknowingly and sometimes knowingly deal with is the social media artificial intelligence application. So there's the saying that the social media companies know you better than you know yourself. And that's because it goes back to the large amount of data. And every time we interact, every time we do anything on any social media platform, they're collecting that huge amount of data. And they're running their own artificial intelligence models to be able to direct better marketing and advertisements towards each user. And so using artificial intelligence to analyze user data is one use case that everybody is involved with, whether they know it or not.
Yeah.
It's also used in all kinds of applications. Otherwise, like even in something as kind of non-tech as agriculture, artificial intelligence is huge in that space. And our agriculture is more of a slow adopter. I have an agriculture background and it seemed to be one of the last adopters of technology as it develops. But one major thing that sticks out in my mind, besides like GPS use within agriculture, is image classification. So a large artificial intelligence problem is how can computers see? So it's called computer vision. And computer vision is basically just trying to get a computer to be able to understand images, to be able to see things and classify it as what it correctly is. And so applying that to something like agriculture, where before currently actually we pretty much spray crops, just blanket spray a field. Whereas now there's companies and technologies available where a sprayer will have a bunch of cameras on it. And as it goes over the field, it will actually identify specific weeds, pinpoint where they are, and it'll just shoot chemical on that specific plant. So it saves up to about 95% of the chemical used. So that is a very difficult image classification problem because you can imagine if you're in a garden trying to see there's all the green colors, but then you're trying to identify weeds that are hiding behind larger plants. And that's a pretty generic artificial intelligence problem, is trying to classify images, for instance.
I'll actually dumb down my question, right? So artificial intelligence, a lot of people think it's magic. So people outside the IT industry think that it's something that just pops up and it can resolve a lot of issues. Can you just give us a view on how do you come about having an artificial intelligence capability? Is it something that is built? Is it taught? How do you, as an organization, now know that you have this capability within your organization? How do you get it into your organization as well?
From an organizational standpoint, a little bit of both, built and taught. You have to have the skill set. First off, you have to have the need within an organization. There's a lot of views that, and they're pretty right, that artificial intelligence is just like any other buzzword, you know, like quantum computing or even ChatGPT is becoming a buzzword. And so a lot of people and a lot of organizations see data analytics as something they need sometimes before they identify what the actual use case is. And so to get it into your organization, the way we approach it in IT consulting is identifying where it would help a company and then identifying what type of data analytics is required to be able to solve those problems, whether it's optimization, whether it's improving their processes or improving their equipment. There's a whole bunch of different use cases. Artificial intelligence and data analytics is a huge area. But if it does fit, then you need either a vendor or somebody to come in with those skills. And those skills help build up that use case into additional use cases. And eventually it can develop into a data analytics center of practice or an entire data analytics team if there's enough work to keep them busy and if the organization finds it valuable enough. But it's important when I guess in my career, I've been working in IT consulting for 7 years. And when I first started, data analytics was hardly on most companies' radars. And then it kind of hit that peak of expectations where every company wanted to analyze as much data as possible. And then it kind of went to that trough of disillusionment where I think a lot of companies realize that there isn't a lot to be gained from some of their data they might have. And so then they just started to take it more seriously and focus on where they could actually get more bang for their buck. And that's when you start seeing the teams being built around data analytics.
Yeah.
And often it's easier for businesses to bring that talent in from even another team that knows how to do it, or an off-the-shelf product, which is kind of the way things are going now, instead of trying to develop that from the skills from a team, from their team skills. If that makes sense.
Actually, your point is leading me to my next question. I wanted to understand, are there any specific out-of-the-shelf technologies or any technologies out there that organizations could consider if they want this capability internally?
Absolutely. It started mostly with back in the mid 2010s, you would hear a lot of users using programming languages and scripting languages, usually R, and then the data science community kind of moved to Python. But since then, in the last decade, there's been a huge amount of data analytics tools that are available off the shelf. And the main one is probably Power BI. So that's a Microsoft product that is pretty much Power Business Intelligence. And they strive to make it look like Microsoft Word or Excel, the tools that everybody's familiar with, but you can plug in huge data sets, make your dashboards. You can even implement Python scripts or R scripts and be able to bring someone in that doesn't have a very strong, maybe mathematical background or programming background, but they maybe have a good UX background or data visualization background, and they can analyze that data and make those visualizations. And a lot of the algorithms and data science methods are already pre-built in, and they can just pretty much click and drag and point and click and be able to do their analysis that way. And then it's gone a step further in the last decade as well, where something like Power BI might be available locally on your machine, or it can be available in the cloud through Microsoft Azure. But now every other cloud provider has their own data analytics or artificial intelligence suite as well. So Google, GCP, Google Cloud, they have their own data analytics suite. Amazon has AWS SageMaker. Microsoft has Azure Analytics or Azure Cognitive Services if it's AI, or there's all kinds of different subsidiaries between each one. And what that allows is for kind of the same thing, where you can bring somebody up that doesn't have necessarily the hard data science background, but maybe they have a data visualization background again, and they can use those tools. And the benefit of that, and the benefit of any of those cloud tools, is that access to that large computing power that's available. So when your local machine won't quite cut it, you can harness the power of several GPUs for a very small fee and be able to crunch a huge amount of data with not as much knowledge as one needed many years ago on what's actually going on behind the scenes. Because a lot of those tools are what you see is what you get kind of editors, where you point and click and go through prompts on what you want to do. Low code, I guess, is a good way to explain it, which means you're not actually doing a lot of typing up computer code. And that's kind of the way the industry is going as far as data science goes, I see. A lot of the hardcore data science, data scientist types, they spend most of their time using something like Python or R, or often C#, JavaScript, other programming languages. But the industry as a whole seems to be working towards that low code type environment where you don't have to know how to program, and you can still leverage data analytics. And it just opens it up to almost everyone in an organization in a sense. So instead of having just one or two people that specialize in data science in your organization, you can have entire teams be able to just look at one tool and do some changing around, and they're good to go, and they can do their own analyses. So it's
Sounds
basically
interesting.
making it easier every year.
Yeah, yeah, it sounds interesting. And Curtis, recently I was just in the news. I saw this something. I think it's an another hyped artificial intelligence tool. It's called Kanye AI, and apparently it will be helping artists or musicians in writing songs and stuff like that. And a lot
Oh,
of people
okay.
are concerned, and a lot of people are concerned that it's taking away jobs from um, people that are currently supporting artists. The
Absolutely.
perception that artificial intelligence will also, the rest of other capabilities will be replacing a lot of people. Is that the case?
Yeah, I think it's a genuine concern for a lot of people, especially artists.
Yeah.
And it's a concern that's an interesting case because it's a concern on a few different fronts. First off, there's a lot of new art essentially flooding the market, so it makes it
Mm-hmm.
much more difficult to get your name out there. But at the
Mm-hmm.
same time, the way artificial intelligence models generally work is they learn from existing work.
Mm-hmm.
So it might be learning from hopefully non-copywritten pieces of art or images, but oftentimes in all reality, it probably does scrape a lot of proprietary work from artists. And the problem with that is now when somebody queries those AI machines to make an image, it's going to lean on potentially some other artist's proprietary work to in order
Mm-hmm.
to generate an image. And that's one of the main concerns, is that kind of plagiarism side of things,
Yeah.
let alone just the fact that there's now anybody can get to their own art.
Is there such a thing in AI though, plagiarism? I thought, can I
Oh,
be detected as plagiarizing if I use AI to get ideas?
it's possible, yeah. So
Okay.
AI is not perfect. Most
Mm-hmm.
people are familiar with ChatGPT, which
Mm-hmm.
is one of the most popular um, text
Mm-hmm.
AI models.
Mm-hmm.
Now it actually works with images and video and audio as well, but it's a chatbot type AI model, and so you can talk to it, you can ask it to do different tasks, all kinds of different tasks actually. So you could ask it to write you a cover letter for your resume, or you could ask it to write a proposal for a company to take your services. And the problem is those AIs are far from perfect. So although they generate very human-like text,
Mm-hmm.
there's little things that they do that are easily detectable by other machines, or detectors they call them. So for
Yeah.
instance, if you tried to use ChatGPT to do some work and you sent it to someone, that person could take that entire body of work, plug it into some of the available AI detectors, and it'll
Mm.
look for things like unusual word repetition, that type of thing. So things that it looks human, but that things that humans don't really do, that
Yeah.
is kind of a common trait between AIs. Sometimes they ramble real bad, or they switch topics. So sometimes you can just tell it's AI generated by looking at it,
Mm.
and sometimes it takes a detector or another kind of algorithm to be able to pick out
See.
those idiosyncrasies. Yeah, but it's
Yeah.
possible, absolutely.
Okay.
And so the plagiarism extends from not only art but any type of work, really, because they all learn the
Yeah.
same way for the most part. It's scraping up huge volumes of data off the internet. Most of that stuff is available free, but it's
Mm.
also inadvertently probably picking up a lot of proprietary work, and then it's using that to generate new text essentially, so which can contain little snippets of the copywritten or proprietary work. So that's
Yeah.
always a challenge.
And my last question, Curtis, is that so if I'm a student and I am getting information from tools like ChatGPT, how do I reference it? And if I've already referenced it, is the information that you're getting from AI tools actually factual? Has it been verified,
Mm-hmm.
or is it something that we'll need to double check and make sure that information is actually correct?
Yeah, so if it's factual, it's pretty accurate, but no, it's not always factual. It often can make up random facts, essentially. It
Yeah.
can provide you a lot of inaccuracy in its answers. So you always double check your work and don't rely solely on any AI generator, because most of them, like I said, they're very imperfect. And most of them you can tell it's AI generated by just, if you really read it closely, it doesn't
Yeah.
quite run right. Either someone's a really bad writer or it just doesn't flow right. And that's what's different about ChatGPT, is it seems to be widely accepted as one of the most human-like ones that has come about recently. But yeah, you definitely want to double check it. And that goes for any, not only for text or any other audio AI or anything that gives you information, but it also especially pertains to AI generators like Codex, for example, or GitHub Copilot, which is AIs that help you with your coding. So some of them you can just ask it a problem. Can you figure out this problem and give me a solution written in Python or written in C#, and it'll do it. But it's also doing the same thing where it's using past examples, millions and millions of past examples that it's seen, and generating its own version of that, which can contain little snippets of either proprietary information, or it could just be wrong as well. And so you always want to double check it, especially with coding. As far as how you reference it, it's starting to become kind of a difficult thing where a lot of these models utilize a transformer architecture now, which is one of the most advanced architectures for natural language processing. And the thing with that is it really kind of does generate its own text. It's not taking blocks of text. It's not using sentences that have been formulated previously. It's doing a lot of the generation itself, which leads to a bit of a black box problem where you can't really tell where that information is coming from. And so it becomes very hard to cite in the traditional sense where you would cite a website or something like that. And lots of these AIs, you can ask it to provide its sources and it will try, but more often than not, I've read that the sources that it gives back are usually not even related to what it was talking about. So it does its best. So you definitely can't rely on the AI to provide sources. And so what is becoming kind of a common practice is actually just providing the AI itself as one of the sources, which is kind of a half measure. But again, there's no real way to find out where it got that information from, because it's really probably consolidating information from hundreds of different websites or text documents or images or video or what have you. So it becomes a pretty big challenge.
Curtis, it was a very informative session. And do you feel like there's something else that people need to know about artificial intelligence right now and going forward before we close off? Is there anything critical that you think this is very important for viewers to know about artificial intelligence?
No, I don't think there's any fear mongering that needs to be added about artificial intelligence. I think overall it's pretty good. There are a lot of challenges that need to be addressed, mainly around, like you talked about, where artificial intelligence replacing people's jobs, replacing entire industries, and those are problems to be solved. But overall, it's a very exciting field to be in. And I guess one thing I would add to get into artificial intelligence, data analytics, or data science in general, to anybody who's interested in it, there's one very, very nice thing about it is you don't need to follow the traditional route of going to university and getting a computer science degree or a computer engineering degree. Although those help a lot, what's nice about computer science and data science is you can take some online courses from home, do a few projects on your own, build yourself a little portfolio, and you could probably get a job quite easily within a much shorter amount of time than most kind of careers where you have to go and get a degree for. And so what's one cool thing about data science and computer science is that it has opened the doors for a lot of people, and the barriers to entry have become really low. Especially most of these tools offer free versions for students. And so my advice for anybody who would be interested in getting into data science is find some area you're interested in, whether it's healthcare or space or agriculture or something, and take some online courses around a tool like Power BI or AWS SageMaker or Azure Cognitive Services, and get to know those tools, get to know those architectures just by taking the free online courses. And then you can easily find positions in companies that are looking for those skill sets. So the barriers to entry are really low, and it's a pretty exciting field. So there's something for everybody in it.
Yeah, Curtis, I'll try and sum up everything you said today, but you said quite a lot, so I may not cover everything. So you mentioned that so artificial intelligence is not a new concept. However, it has been enhanced over the years because of the new technologies that we have, right?
Mm-hmm.
And you also mentioned that people don't need to go to universities in order for them to get set up to be part of this evolution. You also indicated that yes, we can trust artificial intelligence. However, we also need to double check it, double check the facts that they bring to us. And you also
always approach it with a healthy level of skepticism.
Yeah. And currently, you also indicated that it cannot be referenced because it always generates new information. And
in general,
in general. So we cannot reference it in a traditional manner that would reference websites. You also mentioned that it's important for us to distinguish between the information that it provides and the actual information that it provides, and information would get in other sources that we use when we do research.
Absolutely.
Yeah. And then did I miss anything important, Curtis?
I think that pretty well sums it up.
Covered everything, right?
Yeah.
Thank you so much. And hopefully we can see you in the future expanding on this topic, but I think you've shared quite a lot. Thank you so much.
Absolutely. Thanks for having me.
Then. Bye.
Bye-bye.